A rock is thrown horizontally off the edge of a cliff with an initial velocity of 15 meters per second and lands a total horizontal range of 70 meters. How high is the cliff and how long before it hits the ground? Well, okay, so here's my person throwing a rock, and he's on a cliff, and so he throws a rock here, and it goes to there. And so what information does the problem give me? It is thrown horizontally off the edge of a cliff with an initial velocity, and the fact that it's horizontal, mean of 15 meters per second. It also tells me it landed with a total horizontal range, so that's this distance in the x equals 70 meters. How high is the cliff and how long before the rock hit the ground? Well, I've specified that, look, I'm going to go for time fly first. So let's take what I know. I know velocity initial equals 15 meters per second. And I know distance in the x equals 15 meters per second. But I don't have a third. So now I got to think about the rock as it flies. So it travels at 15 meters per second in that direction just as it's thrown. But then what about right here? Is it still traveling 15 meters per second? And then what about right here? Is it still traveling 15 meters per second? Is it speeding up? Is it slowing down? Is it accelerating? Nope. So I apply 0 meters per second squared. The thing that I'm looking for is time, and the amount of time it actually flies. That's going to be in seconds. So now I need an equation that deals with velocity initial, distance, acceleration, and time. Distance equals velocity initial times time plus 1/2 acceleration times time squared. Okay, let's replace letters with numbers. So distance is 70 meters equals velocity initial is 15 times time, which I don't know what I'm looking for, plus quantity 0 times time squared, I don't know what that is, divided by 2. Alright, so if I simplify, this 0 times any number is going to be 0, and then 0 divided by 2 is going to be 0, so that all blows up, giving me a 70 equals 15t. To get t all by itself, I'll divide by 15. T equals 4.6666 yada 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 7 seconds. In order to make it pretty, I need to determine significance. So look at 2 sig figs. Ooh, 1 sig fig. So my answer is going to have 1 sig fig. So that means the 6 goes away, but before it goes away, it gets to round. See this? This is, the 4 is significant. The 6 is not, but it has an opportunity to round before it goes. So 5 seconds, at least according to significance. But listen, I got this really accurate number. Shouldn't I use it for my next one? T equals 4.666667 seconds. And let's see, do I know anything else in the y-axis? Well, I know that velocity initial is always, I know that velocity initial in the y-axis is 0. And I know that the acceleration due to gravity is negative 9.8 meters per second squared. And if I want to know what distance is, that's going to be in meters. Which equation am I going to use? Distance, acceleration, velocity, initial time. Okay. Let's replace numbers for letters. I don't know what distance is, but I do know that velocity initial is 0 times 4.66666667 plus the quantity negative 9.8 times 4.666667 squared over 2. Does this blow up? Distance equals negative 9.8 times. Now if I take 4.8 or 4.6 and I square it, I get 21.77777. I'm seeing a pattern here. 8. All that over 2. You see D equals negative 213.4222 divided by 2. So I get D to be negative 106.71111113 meters. In order to make it pretty, I need to find out how many significant figures, and since there's only one here, I'm going to apply only one sig fig. And so it's going to be 100. I cannot put a decimal or else that would denote 3 significant figures, meters. Now what's interesting is I can make it negative or I could make it positive because I asked about the height of the cliff. I would accept either one.